Welcome to the next session on Module 3, that is Solid Oxide Fuel Cell. It can be abbreviated as SOFC. Solid Oxide Fuel Cell is a device that produces electricity directly from oxidizing a fuel and are characterized by solid oxide material as electrolyte. And these cells operate at higher temperatures around 1000 degrees Celsius. In a solid oxide fuel cell, this is the fuel used, that is hydrogen, oxidant is oxygen, anode is nickel zirconium oxide, cathode is strontium doped lanthanum magnite, and the electrolyte used, it is solid electrolyte, that is a mixture of zirconium oxide and yttrium oxide or yttria doped zirconia. This is the most widely used electrolyte because of its sufficient ionic conductivity, chemical stability and mechanical strength. And the operating temperature, it is around 1000 degrees Celsius. Now this shows the construction of solid oxide fuel cell. It consists of 3 chambers. This is the anodic chamber, this represents the cathodic chamber, and this represents the electrolyte. So 3 bonded layers: anode, electrolyte and cathode. And electrode porosity is required for the gaseous diffusion between the electrode's outer surface and the electrode-electrolyte interface. Electrode porosity means the electrodes used, they must be porous so that gaseous diffusion takes place at the electrode's outer surface or between the electrode and electrolyte interface. So here oxygen, it is supplied to the cathode, whereas hydrogen is supplied to the anode. Here oxide ions, oxygen, it get reduced to oxide ions, and the oxide ions, they move through the electrolyte and they will reach anode, where they will combine with hydrogen to form water. So here, when oxide ions combine with hydrogen to form water, electrons will be released. These electrons, they will move through the outer circuit and again they will be reaching cathode, where they will be used up by the oxygen to form oxide ions, or oxygen to get reduced to form oxide ions. And these oxide ions, again they will diffuse through the solid electrolyte and they will be reaching anode, and this process continues. Here the operating temperature that is required, it is very high, it is about 1000 degrees Celsius, and hence electrocatalysts are not required for solid oxide fuel cells. These are the reactions taking place. At anode, hydrogen will combine with oxide ions to form water and electrons are released. These electrons, they are used up at the cathode for reduction of oxygen to oxide ions. The overall reaction is hydrogen combining with oxygen to form water. Applications, they are used in portable appliances. Then they are used in transportation applications, that is for industrial transportation, public transportation, etc. And here portable appliances means it includes consumer electronics like laptops, cell phones, etc. They can be operated. They can also be used up in backup power. Then in power distribution applications. So these are the major applications of solid oxide fuel cells. Now the major difference between conventional battery and fuel cells. Conventional battery, they store chemical energy, whereas fuel cells, they do not store chemical energy. Then in conventional battery, reactants, they are within the cell, whereas here the reactants are supplied continuously from outside. Then here the electrodes are cheaper and they are consumed, whereas here electrodes are costly but not consumed during the reactions. And here the products formed, they will remain in the cell, whereas here the products, they are removed continuously from the cell. And here secondary cells, they always need recharging, whereas fuel cells, they do not require recharging. Then here the byproducts formed, they are harmful, whereas here the byproducts formed, they are harmless. So these are the major differences between battery and fuel cells. Thank you.